I'm going to go ahead and hit record, and off we go. Just a reminder here, we're going to want everyone to mute their microphones. You can stay on video if you would like, and at the end, we'll announce a interactive Q&A. So I'm Dan Lopez. I'm the Chief Strategy Officer at Arkisys. And what I'd like to do today is give you a quick refresh and orientation around what the port is. And then we'll go into a little bit more detail on the science effort at the port as well. So the introduction to the port is just a refresh, and I wanted to make sure everyone is up to speed with nomenclature. And the port is one or more modules. And so you can see here on the left, this is a configuration of a single port module, as well as on the right, where there's different activity happening at the port. But again, if we aggregate and build the port, the space outpost starts to become much more visible in our vision of what the port actually is. And this is where we'll be conducting our science mission directorate here with Arkisys at the forefront of innovation at the space outpost. So we are also trying to get science experiments and payloads to the port in as fast as 90 days, and that is really enabling us to design missions that are at pace with unprecedented innovation. We can go into a little bit more detail, but the speed to market and orbit operations is something that's really unique to what we're bringing to the table. We'll talk a little bit about security on a different webinar, but this is something that just want to make sure that everyone is up to speed on our thinking about cybersecurity and enclaving as well. That is available on our website. If you go to our website, down at the bottom right, there's a industry day presentation that talks a little bit more about our security efforts as well. Now, to look at the full roadmap of what we're looking at LEO to GEO and many locations after that. And this is how we think about it. Your science does not have to reside in LEO. We want people to think about LEO as a single destination, but it's not the only destination. And as we expand our capabilities, so does your science. And so I wanted to make sure that that was also a very clear and intentional way of thinking about how we're going to be interacting with science. Just to refresh on some port terminology, we're going to be looking at the port. This hexagonal shape has 6 sides to it, and each side has the ability to berth or have something dock at the port. We have something called the pre-berth assessment, where we analyze how best to put your payload on the port. And then the onboarding process is where we go through rapid integration and testing of your payload to get it interface with the port. The bay is where you're assigned, and the interface is where you connect into electrical data, mechanical, maybe fluid interfaces. Again, you'll see that we have a series of different capabilities. The onboarding and getting you into and then docking to the port requires us to think through how to do that, all the way to hosting you and having you then maybe even depart, or the RPO processes that we look at for rendezvous and proximity operations is something that we will walk everyone through during the onboarding process as well. You can see different configurations here for berthing vessels at the port. We have different orientations as well, so we can accommodate different vessels at irregular intervals as well. Here's the customer journey. I just wanted to revisit this. We discussed this at Industry Day, and we've talked to our customers about this, but we wanted to make sure that people understand that they go through a a journey that starts with an online request, or you call us up and we go through a pre-birth check or an assessment where we then validate what you're trying to do. We're looking at where you're going to birth on the port, but then we go through rapid integration with our team on the ground and validate your integration to the port. Then we start the formal process, and then we get you to a physical manifest and launch you up to the port. And this can happen as rapidly as 90 days. So I just wanted to make sure that that is really clear. Dr. Heath Mills will walk through a little bit more about how this aligns with our science customer journey as well. Our online process is really easy. I just want to make sure that everyone is aware that our platform is just getting up and running, but you're able to instantiate this first process of the onboarding and requesting more information on our platform. I'm going to turn it over to Heath, and we're going to open up Q&A again on the tail end of the discussion.
All right, Dan, thank you so much. And I really appreciate the introduction on that. And also the opportunity for us to discuss a little bit about what are the advantages, the processes, and the capabilities for actually doing science on the port. And I will start sharing my screen here in a couple of seconds. Here we go. All right. So what I want to do today is I really want to build on what you just heard Dan saying and develop the concept of science on the port, but also hopefully inspire you to start thinking about your discoveries. I'm not going to tell you what to do with your science. I'm going to tell you what can be done. And then from there, it's up to those that are listening now to really figure out what you want to do in this new environment. So I am with Rhodium Scientific. I will go through and tell a little bit about Rhodium and who we are, as you may probably not, or you may not be familiar with us at this point. But from my background and my standpoint, I am a scientist, and this is something that Rhodium really takes a lot of pride in, that word scientific at the tail end of our name. We are a science-first company. We are a biotech company. And so that's the reason we're working with Arkisys on this, to help develop and really, really enable that science on the port. And it is not a typo in the title where I have the "and" all in uppercase. We really want to focus on not just doing research, but also doing that development. It's great to go somewhere. It's great to go do a project. But if you're not really developing something, why go through that full effort? So let me jump into it, because I want to address a couple things today. I want to address the why, I want to address the how, and I want to address the who when we're talking about going to space. And from the why perspective on this, why go to space, really want to focus on the scientific rationale. That's the focus of today's talk, is on that science. So let's talk about the science rationale. And as a former professor, I really like to look back at the past to understand where we're going in the future. And so if you think about it, exploration for mankind is not new. We've always gone out, we've always crossed horizons, we've always challenged new areas. Well, as the ships left the old world and headed to the new world, like right now, what is happening with space, we're leaving the old world and we're heading up to the new frontier. What did we do? Well, we learned to use the environment that we found. We learned to use that environment out there. We learned how to access the resources. We learned how to take advantage of those new soils, those new terrains. We learned mining. There was gold out there. We learned the resources that were out there and how to gather them and bring them back. We also learned how to build structures out of the materials that we found in that environment. It took a lot of testing, it took a lot of development, but we learned how to live in that new environment. We also found medicines. We also found ways to heal ourselves. We did all of these things to, yes, survive in that new environment. But the big key point on this is we returned those products back to the old world. We found ways of utilizing that new world to develop novel products to then bring them back to those that pretty much funded us and sent us out there to begin with. And so I think this may be a very key point to think about what science is going to be done on the port and the why to go out and do science on the port. Because the products that were developed out there, now the out there could be space, the out there could be in the new world, but the products that were developed out there were returned. So that begs the question, what will be the new products? What will be the new scientific breakthroughs? What will be the new production items that could be done on the port? And this is a picture of the port, and what Dan was saying earlier, this is one of the configurations. So what do we know about this environment? Now, luckily for us, we're not the first ones to go to space. We've been there before. We've been there a long time. And so there's a lot of data out there right now that can be mined to understand what are the advantages for being in this environment. What can we expect? From a biological standpoint, and I'm going to talk about biology, I'm going to talk about chemistry, and I'm going to talk about physics, science. From a biological standpoint, cells, biology, organisms have new physiologies. They act different. They change their metabolic rates. They change what they produce. They act differently than what they act like on Earth. Now, some of these changes may be temporary, the phenotype changes, or they may be a genotype change, which means the actual DNA, the coding of that cell, of that organism shifts. Now, that's interesting because at that point, now we're talking about maybe producing something that is acclimatized to that new gravitational environment. Just like drought-resistant crops have been evolved and changed and developed and spreading out to new regions on Earth, what are the new climate, the acclimation process is needed for gravitation changes? Maybe to the moon, maybe to Mars, maybe to Leo, maybe to Geo. There may be these, new gain of function mutations that are very interesting that are only functional on the port or in space. Now, there's other functional advantages that biology faces when they're in space, and those can be with 3D cell cultures, tissue cultures, new bioprinting options. So on the left, what you see is the why, is the what's happening. On the right, you see those applications. This could be new drug products. This could be new means of developing tissues, new stem cell response, new organ repositories. All of these are the things on the right where I want you to fill in the blank. I want you to come up with okay, we know this happens on the left. What can I do on the right? And what does my business, what does my endeavor, what can I do on the right side? So that's the biology side. Chemistry also has really interesting novel effects in space. There's no density deposition or convection in space. There's no up or down. Combustion reactions are very different in space. The way the fuel is utilized, the way that soot is produced, the way heat is dissipated is very different. There's a contactless processing that can happen in space where you don't have edge effects, whether that's through a flow environment or that's through the building of a crystal. This also allows for microstructures to be very uniform, purity, high purity environment for the production of polymers. And now you get to the right side. So the polymers, the additive manufacturing, Z-blend is always a good one. That's a good example. The formation of different crystals, the formation of different glass structures, metal structures, when they solidify, there's an advantage for being in space. This is and typically not reproducible on Earth. Good thing about the port is the port allows for scalability. How big do you want to go? How many nodes do we want to attach to the port? How many sections do we want to add to the port? It is expandable. Current options right now on space is not that expandable. The port offers that expansion. Physical environment is also very different. The physics has to be understood as well. We know there's differential in gravity potentials, differences in acceleration rates. Distances are much bigger and easier to accommodate larger distances in space than across a terrestrial environment. You also get vacuum conditions. Some production lines require vacuum conditions. Well, there's a big vacuum in space. You get mixed radiation environments, microgravity environments. These different physical environments can add to a unique capability that the port can provide. Now, whether that's testing a nuclear fuel cell, you don't want to do that on the International Space Station. It's not something that the safety teams would appreciate. But on the port, you may be able to test new systems, ruggedize electronic components. You can even do Earth observation. You can do astronomical observations, look up, look down. Understand that physical environment. These are sciences that are available now, again, at scale, without some of the drawbacks that are currently making life a little bit more difficult in other current environments in space. The port's going to open up new opportunities. So with that, I hope that, and it's very brief, and obviously we could go into this for my typical framework is a semester. We can go into a semester after this, but for this, we'd like to have you explore, and we'd like to have these questions come in at the end of the talk today about what your space opportunities may be and the questions you have. But now, how do you get there? Now, Dan provided some background on this. I want to explain a little bit more from the science perspective, because I really want us to focus on that product-driven research and development. We really want to focus on what goes in, the quality in, quality out concept on this. And so with that, let me take a quick pause and just introduce Rhodium Scientific and who we are. We are a woman-owned small business founded in 2014 by Olivia Holzhaus, who's on the call here today. The company was moved from San Antonio to Houston, Texas, and thankfully we've now thawed out from last week. But since about 2016, we've been really focused on space. And so far, we've developed and supported payloads on many different vehicles. We've focused on the International Space Station. We have experience with doing work in space, and we know what it takes to start moving into and moving science into this new environment of the port. Now, as I said before, we are focused on science first. We do have multiple access points to space. We can go from the International Space Station. We can also go into Arkisys. But our focus today, and what I really want to make sure you understand is that we really want to look at that project development side and really work you through this and take away some of those ambiguities of how you get your project and product to and from space. With this science first strategy, we really want to say that we have an industry level quality assurance that we put into each one of these projects. This helps with, say, the biotech industry or any type of recognized commercial industry to understand what the product is that's being produced. We will work with you as a scientist. We're speaking scientist to scientist on this. We'll help translate the languages associated with this onboarding process into the speak that you understand. We'll help develop and optimize the protocol so that the project has a higher chance of success. And then we also have a little fun at the bottom. These are some of the patches that we've developed over the past several missions that we've done, and we're looking forward to building some of these with you guys here. One of the things that we're really proud of is this quick space process, and this aligns very well with Arkisys and that rapid timeline that we're talking about. Rapid does not mean sloppy. It does not mean that we're cutting corners. We have shown through a DoD process that we have developed with the Department of Defense that we can onboard high quality science with that rigor that is recognized by regulated industries. So we're going to embed our quick space process into the Arkisys onboarding process so that we will take care of your project, not only during the pre-flight process, but also during operations in space. Now, here's the slide, and I adapted the slide that Dan showed a little earlier to show that there's a potential second pathway through. So with the science projects, and this is something that we've developed here with Arkisys, is that if during that online request phase, and Dan showed you this, the link to it, I'm going to show it to you again in a couple seconds, that if you're selecting and requesting science support, this opens up the connections into Rhodium. And so what we're going to do is we're going to walk you through a pathway that matches, it parallels, it goes in tandem with the Arkisys process. We're going to focus on getting your project developed, making sure that that project matches the level of quality standard that you are accustomed to in your lab, that it fits within the hardware, that the hardware is available, that it matches your objectives. We're going to get that science integrated into the port. We're going to work with you during the flight operation so that you understand that your project is not just left out there, that we are there and we're supporting the science from a science perspective. And then we also provide an extra service at the tail end that if you want that a continued quality assurance management plan to continue towards and in that post-flight process, we can be there for you as well. We'll also work as the interface with Arkisys. So as some of the terminology may be unfamiliar to you, some of those, the launch speak and those requirements may be unfamiliar, we'll help on that process so that you can focus on doing the science that you know. You're a scientist, you're a developer, you're developing that research that's going forward. You continue to do what you do. We will help with and help bring you to the port and bring you into what Arkisys is producing. And so that's where our role kind of fits in on all this. And so hopefully that's a little bit more clear. Now the fun part, who's ready to go? Talked a little bit about the why. I've talked a little bit about the how. Now we're into the who. And the who is you. Hopefully you are ready to go here. Hopefully you are ready to get into this and start this process. So as Dan was saying, there is a mechanism within the Arkisys website where if you're wanting to ask questions, there's a contact button on it. Click the contact button, ask us some questions. Dan will push it to the right person, make sure the right person asks your questions and give you those questions in a quick process or answers in a quick timeline. When you're ready to start, there is an actual start process, start a mission, start the booking request. So when you're ready to do this, we're here. If it's a science that you're looking for, we're here. And there's also a key little thing here. This is science on the port day to day, but there's also engineers that are needed as well. We don't have all the answers on this. There's a big open window here. If you are a payload developer, a hardware developer, there's reason for you to join in on this conversation and to jump into this topic today, because some of the hardware that you're developing may help our science tomorrow. It may help the science today. We may be looking for you. So it's not just about the scientists that we're looking for. We're also looking for the engineers to help develop, build, put this port together and start moving forward. So everybody, I really appreciate this opportunity to talk today. I am leaving this really open now for the open questions and conversations and everything. My email is on the bottom down here. I hope you will go through the contact line from Arkisys so that we get you into the process and we get you maintained and make sure you're taken care of properly. But I do really appreciate this today, and thank you so much for this. Dan, I'm going to stop sharing this now, and I think we can open this up to questions. If I need to come back into it, I will. But let's do that. Hopefully it's worked out for everybody.
Heath, thank you so much. That was a great presentation. I am going to open it up to the community now here. And let's start taking some questions. Both Heath and I and Dave and Olivia will be able to field questions as needed. All right.
Yeah, hey Dan, the first looks like there's one question that came in about the FAA and FCC approval processes, and that's absolutely a valid question. Our plan is we've actually already started the process with the FCC, which is fairly straightforward in terms of at least understanding how to get frequencies approved. The other process we started is with NOAA that deals with remote imaging. The FAA processes are typically related to insertion into launch vehicle in order to transport up there. So our plan relative to a service agreement is that we will support the payloads in the FAA process by inserting into launch vehicles as required. The FCC process, if you have a specific frequency that is outside the band that we are going to be approved, because we'll have many of them that will be approved to support throughput and data communications. And then NOAA. NOAA itself, we're going to get a lot of approvals for, we actually are going to have many, many cameras on board the port that are looking inward, that'll also be able to look outward. We're going to get all of those approved ahead of time. If there's a key payload that needs specific approval that is outside any one of those three, then we will assist the payloads in going through that process. So in terms of timeline, we will do the best we can to sort of speed that up, but in all honesty, it's really dependent upon the FAA, the FCC, and NOAA in terms of approving processes, improving those timelines. But nonetheless, we have, as a great question, we've actually started that process to at least seed those particularly agencies in order to support getting payloads up. Just a quick background, after a single port module gets up there, we have the intention to resupply every 90 days. So by definition, we have to be constantly going through the pre-approval process, both for going into the FAA, whether it's with a launch provider, making sure that frequency approvals is satisfied relative to the transport mechanism that gets to the port. And then if there is anything additional in terms of payloads that we're bringing on board for remote imaging, whether it's looking out, up, down, whichever, then we also have to coordinate that, because before you can launch, you're supposed to have those licenses. So again, a great question. Our job is to help facilitate that.
We have another question coming in here from Gordon. The alternative to the port is to integrate each scientific payload into a complete satellite. Likely the port will provide a much more cost-effective approach. Absolutely. But the question is, have you an estimate of what a typical scientific mission might save by using the port?
Yeah, hey, that's an outstanding question. So our plan, and we actually presented this at the industry day, and we have several folks that are signing up letters of intent right now, and we supply them a pricing sheet. And in that pricing sheet, everything is based upon a service. We're really trying to make this amortize, the cost of doing business up there, amortize over a number of customers, therefore to keep the price down. The initial estimates that we have, as an example, to lease a payload that may be on the port, something that we bring up, whether it's a sensor, whether it's a camera, whether it's some processing, is anywhere from $50,000 to $100,000 a month. So we're trying to enable that as quickly as we possibly can. The second is this concept of hosting, which means basically the question that Gordon asked, which is taking a independent payload, an independent experiment, a box, whatever it might be, transporting it up, placing it onto the port, and then executing the mission or the experiment that's inside. So we see that as a hosting service, which at this point is anywhere from about $250,000 to $500,000, again, depending upon the complexity. The goal there is to try to enable the experiment, the mission, the engineering to be done as quickly as possible with low cost. And so from our standpoint, in terms of estimating the value proposition to a payloader who might instead have to build a separate spacecraft, is if it's a CubeSat size, that's one cost number. And if it's something larger, well, that's another cost number. But our view is that we're hoping to be able to save between 2 and 5x of what a payload would have to pay to put this up independently. And then in addition to that, we actually have a platform that we can host. And when the experiment or mission is done, it does not mean it's the end of the life of that particular payload. We also have other options that we could explore to either enhance that activity or to put it into a spacecraft that we would actually build on board. So it's actually a great question.
I've got another one coming in here. This is from Julio. When is the port going to be available and fully operative? Dave, you want to take that one as well?
Yeah, sure. So we're working really hard to actually get the very first port module, and the picture that you see there, the thing right in the middle is what we call a port module, to get that up in 2022. So, 2022 goes for 12 months, right? So we're being a little hesitant about saying exact day and exact time. We're actually working through the launch options. We're working through, honestly, attempting to find as many initial, what we'll call pioneering payloads that we want to put up. And the plan is to actually integrate them, host them onto that first port module that will then be launched, and they'll be sort of the first users on the port. So in all honesty, we'd love to maximize the area, the surface area and the use. So at this point, we're actually talking to a number of potential customers that range from literally we're ready January 1, 2022 to we might not be ready until November of 2022. And so we're really trying to work out that balance between getting the first folks up, getting the port module on, and then doing resupply missions after that every 90 days.
Another question, just in terms of timing and cost and how I get engaged. Christian from Boeing has a question about, is this per month? Is this per year for 250K?
Yeah, so we're trying to be realistic about what we think is both the cost to operate as well as a price. So originally we start with per month, and what we'd like to do is that's either per 30 days or per 90 days. So in all honesty, to really get an experiment to work, to get a mission to sort of check things out, it takes some time. So we sort of see the minimum time impulse bit, if you will, to be about 90 days. So again, the complexity related to a payload that goes up there, how much services are required, power, thermal, data throughput processes. Does the payload have any kind of movement activity to it, which might then impact the momentum capability on the port? All of that we see as consumables. We are currently working out a list of what is the standard set of consumables that can support a science payload on almost any capacity. And then from that, we then back into, okay, is it a per month cost? Can it be 250K per 90 days, or is it 250K per month in order to operate?
Great, thanks, Dave. Kelly had asked a question here. Is there a priority and or hierarchy of the types of projects and science to be conducted at the port? Is it driven by your customers who want to get their science on the port, or space exploration, commerce, economic growth priorities?
Yeah, so I'd love to throw that over to Heath and or Olivia, because that you might see that confluence, right? So maybe you can comment on that.
Yeah, I can comment when I get off the mute. Sorry. No, I think that this should be driven by the customers. So there are priorities in terms of when space is limited. And I think that's what we've been used to in the past, is who goes first and who gets to those limited resources. The beauty of the port is that we're expandable and we're able to accommodate new projects, new research on demand. And so timelines can be self-driven. If the hardware is not available, then you may not be ready to fly now. If the hardware is available, let's go now. Funding is always a question mark on this. But within this process, the customers should drive that access. The priority should be on who's ready to go, what they're able to do, and let's get up there and start doing this work now. And so, Dave, I hope that you agree with that. And Olivia, if you want to make a comment on that as well.
Certainly. The comment I'd like to add to that is when we design these and help our customers design these payloads, we always have an interest in designing a program approach. So if it's possible that this science mission can be a programmatic approach where it can be built upon year after year after year, and it's not just fly one time and the end, I feel that the customers get the most value, and the scientific program managers and researchers get more value when we start building science that turns into a programmatic approach.
Yeah, no, thanks, Heath and Olivia. It's interesting to think that, again, everything we're attempting to do on this technical platform is to support aggregation. And essentially what that means is we'd love to be able to convey to potential customers, whether it's science experimenters or other developers of capabilities of hardware for spacecraft or other things, is that you can test incrementally. And that means you can also only expend the capital to test one piece, but then you can also send up another one, which could be aggregated to it, right? So we're trying to get folks to think a little bit differently, that it isn't just a one-time thing, although there will be many tests like that, but that once you're up there, we literally have the ability to move things around and connect additional either capabilities or functions or other add-on payloads that one particular group might have to show an expansion. So the idea that he talked about scaling is absolutely sort of inherent in the technical design. Yeah, thanks.
Great feedback here. Another question to build upon Kelly's is, what are the thoughts on supporting non-commercial student payloads and experiments? And this is coming from Vidushi.
Oh, wow. Well, so yeah, having a small foot into that, I completely, totally support it. So yeah, I get yelled at a little bit by Dan, who's like, dude, this is a business, right? But my thought is, hey, man, let's send everybody up from a student who wants to go up there, right? So we really want to enable that as much as we possibly can. There's no question that an educational discount is something that we have and are considering. And so really that's sort of, we need to figure that out in terms of amortizing the numbers of potential student payload opportunities or faculty payload opportunities that could go up and test and sort of be involved in the activities that are up there, versus how much we can actually charge, because we know schools don't typically make that much. Honestly, that was a great question, Vidushi. And one of the motivators for having what we're calling the very first service, which is a leasing service, is that we intend to put up our own cameras, our own sensor, our own little processor that are not connected to anything else. They're not required for the port to actually operate, but instead what we will try to do is enable anybody who wants to access them. And while you might consider, well, gee, Dave, that's really boring because there's not really much they can do. But in essence, what we're doing is training them to be able to, how do you program? How do you command it? How do you take the data that comes from it and then begin to think about how do you create an experiment which would then sort of expand what it is we're doing? And we're really trying to plan to do that at the lowest possible price we can. So great question, support it. We want to make it happen as long as we don't go out of business. So
right. And just to follow on with that, Dave, like it's very exciting to have students and to have faculty participate in these type of programs, because they are the ideal customers that would have a reoccurring yearly curricula and schedule that would benefit from the access that the port can provide.
Absolutely, appreciate it.
Absolutely. Here's a really interesting question. Dave and I and team have thought about this actually quite in depth. The question here is, how do we plan to address competing pointing accuracy and or field of view constraints between payloads on a large port? That's a great question. We've thought about that quite a bit. Dave, I'll turn it over to you.
Yeah, no, that's it really comes down to scheduling. It's just that simple. So part of the reason that we have this thing called an onboarding process is that we engage really early on with potential customers before you might even have flight capable hardware. That's the whole point. And what we do is we've actually created an internal database that we're using sort of the best data products, if you will, to not only take the information that comes in from customers about their needs, desires, and wants, and this is visceral things: how much power, what kind of restrictions and pointing do you need to have? Do you want to look at the sun? Do you want to look at nadir? Do you want to look at the earth, et cetera? And we actually are creating, is one of the first things we did, is to, in essence, create a series of analysis tools that can go through and do a couple of things. One of the first things it does is, what is the best real estate or berthing location for that payload to satisfy those requirements? So that's number one. Number two then becomes, well, holy crap, we actually have two people that like to have that, because their desires are the same, to be in that spot. So now it goes into another phase, which now considers sort of time, if you will. So that translates to scheduling. How do we maintain enough information flow and experiment time for all the potential disparate folks that may actually be competing with the resources that are on board? So I don't have an immediate answer, except that we've already known that this is going to be an issue, and we're actually creating a scheduling program to optimize whatever it is that we can do. I'm not sure if it was indicated, but one of the things that we have on board the port is a manipulator, a robotic manipulator. The whole point to have the robotic manipulator, honestly, it wasn't necessarily to sort of advance all the great space robotics, but that is definitely a secondary for sure. But the big thing is we want to use 360 degrees of the surface area on board this platform. The only way to be able to do that is to be able to move things around. By being able to move things around, it now means that not only do we have a scheduling opportunity relative to who's looking at what, when, what kind of pointing accuracy, how much thermal load is brought in at one particular time, but it also means that in all honesty, we can move things around. There are about 60 what we call berths on board at least at this point, in this stage, and each one of those are interconnection devices that each experiment can move around to optimize either the scheduling of others or the scheduling of itself or the support services that might be required to actually run the experiment.
Thanks, Dave. Getting into a question here, Heath, I'll turn it over to you to address Thomas's question.
Sure, Dan. It's an interesting question that Thomas has. He posed a question that says a lot of payloads that currently fly on the ISS require astronaut intervention. What level of automation do you anticipate providing to payloads to remove the need for human intervention? For instance, if a payload currently uses the glove box in the ISS, can you accommodate such an experiment on an uncrewed platform? For example, can you scrape a 3D printed part off of a tray that it's printed on? And you're welcome. But so with this, one of the interesting things that you're seeing now with the ISS and the development on ISS is that hardware is trying to become more and more automated. Whereas in the past, there were more crew interventions and interactions required. More crew time was required to physically move things from point A to point B or provide a scraping. A lot of the hardware providers right now are going to automated systems. So as you saw hardware and capabilities evolve from shuttle days to the ISS, we envision seeing that evolution of the hardware and the capabilities from ISS to the port. And one of the big things on that is the automation. So things like a glove box wouldn't necessarily be required for the port because there's no need for separation of two environments for, say, safety requirements. So in this, we are needing new hardware, automated hardware to be developed. There are automated systems that are currently there. There's companies that are flying really involved CubeSats, Cube Labs, entire experiment facilities that are more automated. So there is that framework with which we can jump off from. So looking at things like 3D printing, being able to process the 3D printed materials and bring them to the next location, even through automated systems with nucleic acid sequencing, extraction, and that side, those are all either been developed, being developed, or will be developed. So I think you're onto a really cool point there. And this is where I think that merger between the science and the engineering can take forward, to go forward and move to something really cool. So Thomas, I hope that answered your question there.
Hey, thanks, Heath. One of the follow-up questions here, and this is something that might be posed by, responded by Dave and I, but specifically around the field of view constraints, I think Gordon brings up an interesting point here. What are the, before the sky is darkened by the port or multiple ports, what are our thoughts on the orbit that appeals to several scientific investigators?
I love the shout out that we're going to be so successful that we're going to blanket the entire Earth with a port. So it's a valid question. I sort of take a step back. What we refer to as a port is we do that on purpose. The nomenclature is specific because ports exist on Earth and they exist at geographic locations where it's natural that ships and or trucks and or airplanes can all sort of come together as a nexus point. Um, those locations are geographic, they're sort of defined. In space, a a harbor, if you will, or a geographic analogy or equivalent is the orbit itself. And the orbit itself becomes sort of challenging to figure out how to convey and connect all of the things that want to come together. So in this case, Gordon was asking about how do you convey the best science or the best observation or the best activities in a particular orbit? And then that translates to, well, can you get access to it easily? Does it have constraints related to lifetime that may or may not be more difficult to deal with? If you're in the Van Allen belts, a little more difficult to operate, et cetera. So our first step, our first foray was to try to find a balance that seemed to make reasonable sense between the ability to get transport to the port very quickly and very easily from almost any launch site in the world, as well as a reasonable altitude and a reasonable inclination that allows both looking down at the Earth as well as looking out. That would be useful for both engineering missions, new types of technology components, and science. So it's a great question. Our view, I think, as Dan identified, is that a port is one or more of the modules that are put together to support the capabilities and the customers that are required. And that particular platform can be put into any orbit. So the question then comes down, can we see what the market, if you will, or the science is really driving, that you'd like to be either above the Van Allen belts, maybe you want to be inside the Van Allen belts, maybe you want to be at geo, that the harbor, if you will. The good thing about our port is we can literally move it to wherever the harbor is, whatever orbits would be there. Dan, there was another question that was sort of along those lines that talked about the transport to actually get there.
Yeah, go ahead.
That's a beautiful question as well, because again, we're using the nomenclature of not only a port, but also the vehicles that come to us as visiting vessels. It's exactly the same thing as you see, nomenclature on the Earth. To be effective, you have to be able to take advantage of every transport service, whether it be private car, FedEx, DHL, UPS, it doesn't matter. In our case, in orbit, and this is also part of the reason that we selected the first orbit to be in the LEO regime, is that we're reaching out to small launch vehicle providers, those that have upper stages that they wish to have greater capability for either accuracy to achieve a particular orbit or to have more delta V. We're reaching out to OTV providers, those that are up and coming, those that have already demonstrated some capability. And we're also working on something that we call our own standard platform. Every one of those we've reached out to and offered to them basic interfaces and connectivity to enable them to come to the port. So it's a beautiful question to ask about specifically transport. The other thing that we've done on board the port is we will have RPO sensors, not because we're going to be moving to connect to it, but instead what we're really trying to do is to open up the space of transparency to make it as simple as possible for any vehicle to visit our platform, and we'll provide reverse RPO, if you will, to enable them to actually get up and close to us. And then that last sort of couple of meters, once it actually gets to that point, is the arm that goes out, connects with it, brings it in, and then we have some deployable structures to be able to berth a visiting vessel. So I'll stop.
Excellent questions from the community here today. There are a couple more have come in. I do want to make sure that we give everyone a fair chance, but we also, with a few minutes left, I did want to make sure that everyone knows where to find us, and feel free to get in contact with us about our science directorate and getting up to speed on getting your mission and our business up to the port. Again, as David mentioned, we do have specific timelines to get us up to orbit. So we want to work with everyone that is interested to get their payloads up to the port. One question or comment from Gordon, there was a study from JPL and Maxar that they did in 2019 called the Science Station. I'm not sure if everyone knows about that, but it was an interesting study. And the comment was that the port could fulfill this role. And we again, as Dave was mentioning, we are going to be able to, the architecture of the port is to respond to business needs for each one of those orbits that we're looking at, the markets that each market pertains to each orbit. So I put it back to the community and tell us how can we best respond to your needs and get that question and answer started with how to best respond to your specific needs and the market needs. Anyway, Dave, if you wanted to close out as well, just with a few minutes, we want you and Heath to respond as we only have a few more minutes left.
No, very, very much appreciate, especially all the questions. Sort of to close things out, to sort of wrap up Gordon's comment and suggestion. The idea that we are thinking very, very hard in designing the technical pieces to connect together and aggregate to grow is something that we actually want to convey into the customer community. We really are trying to get away from what is typically considered monolithic to things that make sense in terms of aggregation. So it's a valid point potentially that as we've talked about, a port is one or more port modules. So those hexagonal things that you see, we have designs where there's 2, there's 3, they're in a 3-dimensional stack. That's the cool thing, is we've designed it specifically to allow us to add additional port modules, such that as exactly what Dan said, and honestly what he talked about, is it very well could be that a port module becomes a biological science experiment module, or it becomes observations for weather systems where all the sensors are on one module looking down. The idea that you can do multiple things is valid. Yes, you have to solve the problem of the typical systems engineering, spacecraft engineering issues of pointing and thermal, jitter requirements. All that stuff has to be solved. Our plan is to address it as deeply as we possibly can, and then going back to the question of how do you get all these things to play together? Well, it's going to have to be scheduling. Again, it's sort of rethinking the process of not just it's our payload, it's our spacecraft, we're going to do everything about it, to we now have the opportunity to integrate and collaborate. That's the other thing, with a whole bunch of other folks that are on the port, which my hope is would help Heath and Olivia from a sort of a science expansion standpoint. So Heath, I'll hand it off to you. I think it'd be great to close up.
Thanks, Dave, and thanks, Dan. And just building from that, I love the organic nature of this. I'm a biologist, and so as this process grows, as the opportunities grow, we look forward to stimulating that growth and culturing and nurturing that growth. But I think you're exactly right. It is something that this community needs to come together and can come together. And don't be shy out there if you have only a piece of that puzzle and you're looking for the engineering, or you're looking for the science, or you're looking for the financial support. You're looking to reach out to us, because the more that we hear these needs, the more we can start connecting those pieces of those puzzles together so that we all can grow together. So really throw out those ideas and engage with us, talk with us. Let's stay inspired. And Rhodium is really here and looking forward to supporting Arkisys on this, and really appreciate this merger, this partnership together, and this teaming that we're doing. And Olivia, if you want to add a quick bit from a Rhodium side, I'm passing it to you.
No, thank you, Arkisys, Dan, and Dave. Thank you for hosting us and everyone that attended, and look forward to putting your science on the port.
And with that, everyone, thanks again, Heath. Thanks again, Olivia and Dave. I'm going to let everyone go, and feel free to get in touch with us, and we'll talk soon. Cheers, everyone.
Cheers.